Okay, let's unpack this. The pain of trying to squeeze like three colleagues into a tiny, grainy webcam frame for a meeting, right?
Oh, yeah. You're all awkwardly hovering over a laptop. Someone is always cut in half by the edge of the screen.
Right, and the lighting makes everyone look like they're broadcasting from a literal cave. It's awful.
Well, the geometry of the modern meeting room is, it's fundamentally broken. We've thrown a ton of bandwidth at remote work. But the edge device, the camera itself, is usually the bottleneck for real human connection.
Which brings us to our deep dive today. We are looking at the spec sheet for the Captivate HT-4K-DUAL auto-framing 4K ePTZ camera.
Yeah, from HDTVSupply.
Exactly. And it retails for $1,200, claiming to permanently fix that broken geometry. So we really need to figure out, how exactly a single device justifies that premium price tag.
Right, so it really starts with raw light gathering. They're using a 12.8-inch CMOS sensor paired with a 100-degree wide-angle lens. But the key thing, the most crucial metric here is the signal-to-noise ratio.
Clocking in at over 50 decibels. Right.
Exactly, over 50 decibels.
For the audio and video engineers listening, 50 decibels of SNR on a video sensor is massive. But what does that actually look like when you're stuck in a strangely shadowed conference room?
Well, think about what low light actually is. It's really just a lack of photons. When a cheap sensor stars for light, it just guesses what those missing pixels should look like.
And that creates that fuzzy, awful digital noise.
Yes, exactly. But a 50 decibel SNR means the sensor's threshold for telling actual light signals apart from background electrical noise is incredibly high. It doesn't have to guess.
Oh, wow. So the picture stays clean because the hardware is actually sensitive enough to capture real data even in the shadows.
Exactly.
Okay, so we have this massive, clean 4K canvas. But a wide-angle lens usually means you look tiny, like you're sitting way at the back of the room.
Right, but this is where the hardware feeds the software. The spec sheet highlights AI auto-framing.
Yeah, I wanted to ask about that. How is it manipulating the canvas?
So there's a face detection algorithm that continuously scans that massive 4K field of view. It finds the humans in the room and mathematically calculates how to crop and center the group.
I'm a bit stuck on the logistics there, though, because if I get up and walk across the room, the camera has to track me.
Right, it does.
But relying on a mechanical motor to quickly follow someone during a presentation, that seems risky. They lag, they wear out. Plus, that mechanical whirring noise is incredibly distracting on a call.
That would absolutely be true for a standard PTZ camera. But what's fascinating here is that this is an ePTZ. That stands for electronic pan, tilt, and zoom.
Wait, so there's zero mechanical movement?
None. It's completely static. Imagine spreading out a massive high-resolution paper map on a table. That map is your 4K sensor's view.
Okay, I'm picturing the map.
Now, the auto-framing AI acts like a magnifying glass gliding silently over that map. Because it has a 10x digital zoom and millions of pixels to scale, it mathematically shifts the viewing window.
To wherever you are in the room.
Exactly. Zero moving parts, zero mechanical noise.
The magnifying glass analogy makes perfect sense. Silent, instantaneous framing.
Yeah.
But tracking my face flawlessly doesn't really matter if it sounds like I'm talking from inside a tin can.
True. And the Captivate tackles that with a 4x MEMS microphone array capable of capturing audio from 6 meters away.
6 meters, that's nearly 20 feet. That is a huge radius.
It is.
At that distance, it's not just picking up my voice, it's capturing the HVAC system, the fluorescent lights buzzing, someone typing furiously right next to me.
Which is exactly why the raw audio capture is paired with dynamic noise suppression algorithms.
Yeah.
It isn't just applying a generic mute filter.
Right.
The software actually maps the acoustic environment. It isolates the rhythmic continuous frequencies of an air conditioner or a fan, and it effectively phases them out.
While prioritizing the variable frequencies of human speech.
You got it.
Yeah.
It isolates human speech, silently frames the subjects, and pulls clean light out of dark rooms.
And from what I understand, this all requires zero IT infrastructure, right? It just uses a built-in mold clamp and standard USB 3.0 plug-and-play.
Yep. It's essentially a fully automated production crew packed into a single localized device.
Which leaves us with a really fascinating paradox to consider, because as AI completely takes over the heavy lifting of our video calls, always keeping us perfectly centered, perfectly zoomed, and beautifully lit, will this hyper-curated digital presence actually make remote work feel more intimately connected?
That's the big question.
Right. Or does the absolute perfection of the frame strip away the authentic, messy human element of simply sharing a space together? Something to think about the next time you log on.